7.2, Ellipses and Circles. So the definition of an ellipse is a locus of points in a plane such that the sum of the distances of from two fixed points called foci is constant. So we will look at how to draw an ellipse, and I think it'll make more sense then. But basically what you have is you have this locus of points, which is really just our ellipse shape. And then the sum of distances from so here's one of our foci, here's the other, and sum means I'm adding these two together. So this plus this one over here. And when I add those together, it doesn't matter what point I'm looking at, the sum will be the same. So the sum of A plus B is going to be the same thing as the sum of C plus D. So all the way around that shape. And I can show you by drawing that in class. So I always think it's good to kind of quickly look at that definition, even if we don't worry about it a whole lot when we're actually graphing. So this is our standard form for the equation of ellipse. You'll notice I have an x minus h and a y minus k. So we're still always starting with that hk, but this time it's not going to be our vertex. This time it's going to be our center. So our center is hk. And I don't want you to really get hung up on the A and the B because your book is going to switch them depending on which one's bigger. So with an ellipse, I just remember that size matters. So with an ellipse, size matters. With hyperbolas, it's order, but with an ellipse, it's size. If my x is over my a squared, then we are going to stretch a units in the x direction, and x would be right and left. And the y is over b, then we're going to stretch b units, and then in the y direction, which would be up and down. This will make a lot more sense when we actually graph a couple. So I just wanted to kind of quickly look at what these could look like. So we could have an ellipse that looks like this. So here's my center. So that's my HK. And what I mean by stretching A units right and left is this is A, and this is A. And those points on the ellipse are my vertices. So that means we have a vertex over here. We have a vertex over here. And because it's stretched more in the x direction, my x-axis is my major axis. Is your major axis. And because it's not as tall as it is wide, our y-axis is the minor axis. So if this is A on both sides of my center, I told you that up and down would be that other number. So this is B, and this is B here. So that's our vertical number. So it is possible that we could have our ellipse oriented the other way. If we have our ellipse this way, my center is still that HK in the middle, but this time it's up A and down A. They usually use A for the bigger number, but again, I don't really want to get too hung up on which one's A, which one's B. I just want us to have a picture of the graph. So in this case, my major axis is Y. And my minor axis is X. So that means when I go to the right and left, that's going to be B. The other thing that we should add is that our minor axis is our co-vertices. So this would be a co-vertex. So co-vertices would be plural when we talk about them together. I'm going to add that to the other one too. So the minor axis, you can tell co-vertex sounds not as important as vertex because they are on the minor axis. Minor being smaller. And so I would have a vertex up here and a vertex down here. Or we could draw an arrow to both of them and say vertices, but I think that gets really complicated. I think vertex on both sides is probably better. That's a little bit messy now. So these are just basically like all the parts of an ellipse. And I know that they have some diagrams in your book where they're going to talk about coordinates of vertex from the center. We're really just going to graph and get them that way. We're not going to worry about memorizing all those little formulas. So let's go ahead and take a look at a problem that has some numbers. So when I look at number 1, the first thing I want to do is figure out my center. And if it says x plus 2, y minus 1, my center is negative 2, 1. So we're used to having that be a vertex, but the vertex is actually a point on the shape, and this isn't actually a point on the shape, it's a center, so it's a little bit different, but it's still where I start graphing from. So I'm going to go ahead and graph negative 2, 1. And now I need to worry about the 9 and the 4. So because the square root of 9 is 3, I'm going to do 3 units in my x direction, so 3 units right and left. And I'm actually writing out way more words here. I would never write all this down if I was actually solving on my own. But when we're doing notes, we try to add extra detail. So that's because this is a 3 squared, and the 3 is with my x. Now the y is with the 4, and y is 2 squared. So we're going to go 2 units up and down. So 3 units to the right, 3 units to the left from the center, and 2 units up, 2 units down from the center. So now we're going to go ahead and connect it. So that's going to be my ellipse. And ellipses I find are way harder to draw than circles, just so you know. A lot of times they look like kind of funny looking circle rectangles. So there's my ellipse. So that was our third step, is just to connect. So now we're going to get our important characteristics from the graph. I know it doesn't say that, but that's going to be a big part of your homework, so we should probably do that here. So we're going to find characteristics. And then always we work from the graph. So what this is getting at is we want to find our vertices. And we want to find our co-vertices. And we want to find our foci, which I think we neglected to mention on the first page. So when we get down to foci, I'll flip back and we'll add that into our notes. So my vertices I know are on my major axis, so I can tell that this is wider. My major axis is my x-axis, so I will have one of my vertices over here, and I will have the other one over here. So I'm just going to call them v sub 1 and v sub 2. So I need to come up with their coordinates, and I'm just going to count on my graph. So I have negative 5, 1, and the other one is at 1, 1. So again, I am not using any kind of equation. I just graphed by counting, and then I'm going to get my numbers, my coordinates right off the graph. My co-vertices would be on that minor axis, so negative 2, 3, and then negative 2, negative 1. And so again, to give you a little picture, because it was wide, my vertices were here, and my co-vertices were here, just so you're really clear on what we're doing. So foci is the last thing. So I'm going to go back a page, and we're going to add that into our notes. So those 2 fixed points, the foci, that was kind of important to the definition, but not so much when we're graphing it, but we care about it because it's important to the definition. And so the foci, we're going to use the letter C to represent that. And C squared is going to equal A squared minus B squared. And I've told you not to get hung up on A minus, or which one's A and which one's B. So we need to always subtract them. So we have big minus little. And so I don't worry a lot about which one's A and which one's B. I just make sure that I'm subtracting so that I get something positive. So again, A and B are going to come from these denominators over here. The foci is that distance. The foci is that part of the definition where we're talking about how we create an ellipse. So I'm going to go back over here. So in order to find my foci, I know that they are going to lie on the major axis, and the equation is this: c squared equals a squared minus b squared. So my a squared and b squared are 4 and 9. I want to subtract them so that I get something positive. So I'm going to write c squared equals 9 minus 4. So c squared is 5. And so then I take the square root. Absolute value of c is square root of 5. C equals plus or minus the square root of 5. So if my major axis is my x-axis, sorry, and my center is right here, this is my center, then I know those foci, because they lie on that horizontal major axis, those foci are going to be over here and over here. So they're going out on the major axis, but from the center. And in one direction, I'm adding square root of 5. In the other direction, I'm subtracting square root of 5. But remember, these are dead level. This is on that major axis. So I'm not changing my y, I'm only changing my x. So this point over here would be negative 2 plus square root of 5, comma 1. And this point over here would be negative 2 minus square root of 5, comma 1. So the foci really lie inside that shape. I think that we need to point that out too. So my foci are going to be like, let's just say here and here. They're going to lie inside that shape on the major axis. And again, they're really only important when I am drawing an ellipse. And you could Google drawing an ellipse by hand, but I will happily show you that either video or just me doing it myself if I have the right materials at home. So the coordinates of my foci, I don't have to write as two separate ordered pairs. I could just write negative 2 plus or minus square root of 5, comma 1. So those are going to be the coordinates for my foci. So we have another ellipse that we want to graph. The problem is it does not look anything like it's supposed to. I don't have any fractions. I don't have any quantities squared. So first we're going to have to write in standard form. So first, standard form. So lots of completing the square in this chapter. So in order to complete the square, I want to get the constant on the right. And my x squared is already by my x, so that's a good sign. Sometimes they put the x squared and y squared together, and we kind of have to fix that. So if it's a minus 3, I'd want to add 3 on both sides, so I'm going to write equals 3. And then I'm going to want to factor the 4 out of the first two terms because I just want x squared. And I'm showing probably almost extra work to just kind of stop at this point here. And I'm writing the y squared minus 10y in parentheses, even though they're not really necessary. But I'm trying to just point out how I'm going to be completing the square for the x, and I'm going to be completing the square for the y. So I'm trying to look at those two separate parts. So half of 6 is 3, and 3 squared is 9. So I'd want to have x squared plus 6x plus 9. That would complete the square here. For my second one, half of 10 is 5. 5 squared is 25. So y squared minus 10y plus 25. So over on the right, I'd have to have 3. And then I'm not going to add 9. I have to be really careful. This 9 is in the parentheses, and I have a 4 out there. Really, it's a 4 times 9. Really, it is a 36. So when I add the same number on the other side, I'm going to have to add 36. And then I have a plus 25. I also need to add 25. So now I'm going to do my factoring. So x squared plus 6x plus 9 is the quantity x plus 3 squared. And we have a 4 in front. And then my next one factors as the quantity y minus 5 squared. And then on the right, I need to go ahead and add, let's see, 3, maybe I'll add the 36 and the 25 first. That's going to be 50, 61, 60, so fix 64. Now I need this to equal 1, so I'm going to have to divide by 64. You can tell there's really nice numbers in this one. So the 4 over 64, I can reduce this to the quantity x plus 3 squared divided by 16 plus the quantity y minus 5 squared over 64 equals 1. So my center is going to be, the screen does not want to stay up. My center is going to be -3, +5. My x is +3, so my x value is -3. Y -5 means my y is 5. So -3, 5. And now I need to think about how wide and how tall I'm stretching my ellipse. So the x is over 16, and 16 is 4 squared. So in my x direction, I'm going to go out 4 units. And my y is over 64, which is 8 squared. So for my y, I'm going to go up and down 8 units. 1, 2, 3, 4, 5. And I think it's going to have to stretch a little bit in order to fit. It's going to be off the page, isn't it? It's going to be like way up here somewhere. And I did not mean to do that. So we're just going to pretend it's right there, even though it's really not. It's kind of up off the screen. Maybe I should just do that. Probably should have moved my graph down. So there's my ellipse. They're not asking me to come up with coordinates on this one for anything, but I think we should do it anyway. Our major axis is the y-axis, or they might ask you horizontal or vertical. So I'm just going to write vertical. I want us to get used to thinking about that all those different ways. My vertices, and that's going to be kind of tricky because one of them is off the graph. So my vertices are -3, -3. And the other one would be -3, comma. So my graph ends at 10. I started at 5, and I needed to go up 8 units. So it should be 8 plus 5 is 13. My co-vertices would be at the right and left this time. That's why I really wanted to do this one, because it's backwards from before. It's nice to see one where your major axis is the y-axis or vertical instead. So co-vertices are, and again, just looking at the graph, it looks like -7, 5, and 1, 5. All right. And I could go find the foci also if I wanted to. I think we're going to skip that on this one. It's not scrolling well, and we've got a lot of notes here. So just like before, when we're looking at parabolas, first we want to practice some graphing, and then we want to look at what if they give us some information? Could we figure out the equation for that ellipse just based on the information? So they're giving me major axis points, minor axis points. So a major axis is from here to here. That's giving me my vertices. When they tell me about the minor axis, that's giving me those co-vertices. So let's go ahead and just start by, I always do it this way, I always start by graphing the info we have. Because we're going to be able to just draw the ellipse after we do this, and then we can kind of think about what else we need. So 5, -2. 5, -2. -1, -2. It's kind of messy, but we're making it work. You know what? I think I am going to fix that. It's going to bug me. So 5, -2, 2, 0, 2, -4. So the cool thing about graphing this is I don't have to do a midpoint formula or anything else to figure out where that center is. I can just look at this and find the center. So I can tell that my center is going to be right here. And my center is 2, -2. So all I did is I just eyeballed it and I said, well, the center has to be in the middle. And then I went ahead and picked out the center. So I am finding the center. So we're going to find info for our equation now. So our center is going to be 2, -2. It looks like my major axis is in the x direction. And if I look at the units from the center to one of the vertices, it's 3. So I know that my A is 3. From my center up to the co-vertice, I can just count the squares. There's 2 squares. So B equals 2. And then I know that I can go ahead, once I have those three things, I can go ahead and write an equation. Write equation. So we always start ellipses with x. Kind of hinting at other shapes won't go like that. So x minus, my x value at the center is 2. So x minus 2 squared over, the number that matches with the x was that 3, because I had 3 units on the right and the left of my center, and 3 squared is 9, plus, now I have y minus, the center value for y is negative 2, so it's really y plus 2 squared over, and then look at my graph. In the y direction, it was stretched up 2 units and down 2 units, and 2 squared is 4. And then we know ellipses we write are equal to 1. So we're all set. So it might not seem like we really have enough information, but they're always going to follow this form. All we really need is a center, and then we need to know how wide it is and how tall it is. So that's really all we're looking for here. All right, next page. So we're given vertices and foci here. So when we're given those vertices, that's going to tell us stuff about A. When we're given the foci, remember that letter is C. But I'm still going to graph here. That's always my first step. So first I'm going to graph the given information. So let's see, 3, negative 4, and 3, 6. And we can always find our center. Center's halfway in between those. I don't have to have points all the way around to tell where the middle is. So my center's going to be here. So I've already got the center. That's part of what I had to identify. So my center is at that green point, 3, 1. We'll call that C. Let's see, the foci I have at 3, 4. And at 3, negative 2. So here's my foci. And these are my vertices. So in order to find that B value, how wide it is, I'm going to have to use A and C. So remember, we've got this equation, C squared equals A squared minus B squared. It should remind you kind of the Pythagorean theorem, but it's not quite, with minus sign instead. So I know that C is going to be that distance from my center to the foci. So what I see over here, from my center to the foci, I probably shouldn't call this a C. I should call this a center. So from my center to my foci is 3 units. And so I'm going to call this 3. Okay, now when I am looking at my vertices from my center up to my vertices, that is 1, 2, 3, 4, 5 units. So that tells me that A is going to equal 5. So now I have everything I need to solve and find B. So let's go ahead and substitute. And we'll square our numbers and subtract B squared on both sides. Or sorry, subtract 25 on both sides. So I have negative 16 equals negative B squared, which just means 16 equals B squared. Now, because the equation itself has a squared value in it, I'm just going to go ahead and stop right here. I already have enough information to write my equation. So I have x minus, my x value at the center is 3, and I'm going to square that. And that's going to be over, let's see, in my x direction, that was what I was solving for, right? That goes with this b here. So it'll be over 16 plus y minus, my y value for the center is 1, so y minus 1 squared. And in the y direction, it was up 5 units or down 5 units, and 5 squared is 25. And so we're done again. It's almost like magic, I feel like, when you're writing these equations for ellipses and circles. It just seems like there's a lot of weird parts. It should be more difficult than that. So eccentricity of an ellipse. Here's just some info. We're not making a big deal out of this here, but I still want to make sure you see it. Ratio of C to A, values between 0 and 1. It's just really a value that shows you either how circular or stretched it is. So the equation for that is just E equals, ratio is just dividing, right? So C over A. And remember, the C is from the foci and the A is from that major axis. So it's just a measure of how stretched something is. So we'll do one quick problem like that. If we're trying to find the eccentricity, we're trying to find E equals C over A. A comes from the big number here, so if this is 64, 64 is 8 squared, A will equal 8. Then I need to figure out C. So B is going to be 6 squared is 36, B is 6. So A squared minus B squared, then we substitute everything in. C is what we're looking for from the foci. (64 minus 36 is 28. Take the square root. And so C is equal to plus or minus 2 square roots of 7. Really, we just need to worry about positive here. So E will equal, C is 2 square roots of 7, and A is 8, so divided by 8. And so this is approximately 0.66. I always like to divide them out and make sure I really have a number between 0 and 1, because that's what I'm expecting. So next is standard form for equations of circles. So we want to first think about how with an ellipse, we have that x minus h squared, and it's over a squared or b squared, whichever one's bigger. We're not going to really worry about it. And then we have y minus k squared over b squared equals 1. So what if a equals b? So if a equals b, if I think about my center and say they were all 2, then I would go up 2 units, down 2 units, right 2 units, left 2 units. Then I would have a circle, wouldn't I? So it also means I could write my equation as x minus h squared, quantity squared, over a squared, plus y minus k squared over, again, a squared equals 1. And if I multiplied that entire thing by a squared, then I would have x minus h squared plus y minus k squared equals a squared. And a would really be my radius. So I don't think you need to write all of that down, but it is kind of nice sometimes to see where these equations come from. And this is my standard form for equations of circles. And it comes from that. It's really related to an ellipse. It's just a special ellipse where we have the same units up and down as we do right and left, where those denominators would be equal. I'm stretching it the same amount in the x and the y direction. So our last example is just looking throughout these equations and seeing if we can use some common sense to figure out what kind of equation we're looking at. So what I notice on A is that I have x squared and I have y squared. So they're both squared. The other thing I notice is that the coefficients are not equal. That means they're going to be stretched different amounts in the x and y at the end. And so we have an ellipse here. For B, I am noticing that my x is squared, but my y is not. X is squared, y is not. So if only one of them is squared, I don't have an ellipse or a circle, I have a parabola. And for C, I can see that both are squared again. And Both the x squared and the y squared have the same coefficient. So if my coefficients are equal, then that means they're stretched the same in both the x and the y direction. So I have a really specific kind of a circle, or kind of ellipse, which is a circle. So that's how we can tell that. Just checking, making sure we're done with notes. So this is our 7-2 notes. Please work on the homework. Come into office hours if you need help. And we will definitely review some of this in class on Thursday. Have a great day.